This is what we're making today, a square ring. Yeah, I know, who said rings had to be round? For something just a little bit different. Another book from my library. So this is Revere's Professional Goldsmithing. It's a really good book. I've taken quite a few things from it for my classes. We're not making anything out of it today, but I'm using a chart in the back that is for ring sizes. And there are an awful lot of good charts and formulas for doing different things in jewelry. And this is just part of the big mystery of jewelry. Good information. Now the reason I'm using this today is for different size rings. Now Australian and British uses the alphabet, and I've done a little bit of research for the thing we're doing today, and I know size O and size V. Yeah. So V is 10 3/4 US and O is 7 1/4. So if you get a conversion chart, you'll be able to convert to whatever country you're in. I'm going to work in millimeters, I always do, so hopefully this doesn't make it too difficult for you. We're just going to measure the inside of our ring sizer, and we'll get the size in millimeters. And O is 17.4, and a V is 20.2. You'll see the relevance in a minute. Now we're going to make a square ring, and with my experimentation, what I figured out is to make a size O, you do your normal calculations, which is diameter plus the thickness of your wire or height times pi, and then you add 6 millimeters after all of your calculations are done. The V, you do the same thing, diameter plus the height times pi, and then you add 12. So if you want to do something in between, or something slightly bigger or slightly smaller, you'll have to interpolate, which just means you adjust your figures where you think they should be. So we're going to make a square size O ring. So that is 17.4 plus 1.5, which is the wire I'm using, times 3.14. So that gives us 5934. Now we add 6 millimeters. .34. So I'm going to cut that to that length, file the ends smooth, flat. I'll have to anneal this because I've work hardened it, rolling it half round. And then I'll just form it around into a regular oval, solder it with hard solder, round it up like I would a regular ring, sand the join, and then when it's all done, we'll form it into a square. I was assuming a lot. If you don't know what annealing is, if your metal is too hard to bend, you just heat your metal until it's a dull red, quench it, and then it will be soft and easy to bend. So dry it off, use your flat half-round pliers. Half round goes on the inside. Form it into whatever shape you need so that the ends fit perfectly. If they don't fit perfectly, what you can do is hold this, so you can see it's a bit of an oval. You can hold this on your bench, squeeze together so that the ends stay together, and then saw right in the join at a 45-degree angle. And a lot of people get confused about this, so I'll zoom in and show you exactly where I want you to saw. So I've got the join over at the edge of my bench peg, and you put your blade right at the top of the join, and you're sawing at a 45-degree angle, so that when you saw through, the ring will come together. Now this is quite a large bit that doesn't line up, so you just keep doing it again and again until it actually lines up. Yep. A lot of people have trouble getting this bit of the ring so that there's tension between them. Sometimes you can just use this like a jump ring. You push this sideways, push the metal past itself, bring it back, and there'll be tension. If that doesn't work for you, get yourself a set of these ring bending pliers. It's something that you need to use judiciously, and just a small amount of pressure opposite your join will bring that together so that there's tension in it. Yeah, just get a cheap pair of these. There's expensive ones and cheap ones. The cheap ones work just as well. I have the ring, the join is good. I have the ring held joint up. Small amount of flux, top and bottom, and this is just borax based flux. 2 bits of hard solder that you place with your flux brush, and this we're going to put right on top of the join. Now, a neutral flame, and we're just going to brush the flame on and off our join. We don't want the solder to jump off. Keep your solder pick handy, because this is where you can use it to push the solder where you want it to be. Yeah. So now I'm about 60 mil away, just brushing the flame back and forth, staying on the metal. The flux will go clear there and the solder will flow. Perfect. If it doesn't flow where you want it to, bring it back up to temperature and use your solder pick to push it where you want it. Quench it, pickle it, and round it up. But just round it up on your ring mandrel with a rawhide hammer. I can hear you. We're making a square ring. Indeed we are. But it's easier to clean up your solder on the top of a curve than it is on a flat. So trust me on this. Sand your join now. Hallmark the ring, and then anneal it again. The reason I have you hallmark the ring now while you're sanding it is so that you can sand those bumps off at the same time. 400 grade paper on a sanding stick, and follow the curve of the ring. When you've finished sanding this back, you won't be able to see where the solder is. And the reason we sand this back so that we have this almost invisible line where we've soldered is that solder oxidizes differently than the sterling. If you have a large batch of solder that you haven't sanded off, after you wear this a couple of days, the solder will be quite dark and the ring will still be shiny. So sand that back until there's just the tiniest line going across at the join. We'll be using a split mandrel to tidy up the inside. I usually just hold it in my fingers. You can hold it with a ring holder if you want. If you did a good job fitting this and didn't use too much solder, there won't be much to clean up. And just like the outside, the solder joint should be pretty much invisible. Now when you anneal your ring the second time, and remember that annealing is a lower temperature than soldering, so your solder should never run. If you look, you can see a couple of small spots of solder that I didn't get off. You can see the join, which is good, that's fine. But go back and sand these little bits off. Otherwise, when you wear it, it'll show up as tarnish, and we don't want that. Sand those little bits off, and we'll be ready to form it. Okay, we're ready to form. Now I have a square forming mandrel, and what we want to do is we want to put that join on one of the flats. We don't want it on a curve or on the point, because that's asking too much of it. So now we're just going to take our rawhide hammer turn it over because we don't want it tapered. And that's it, really. It's got a little bit of a dip in it. Just continue forming, that'll come out. And the test is whether it's really an O. And it really is. So part of the big mystery is just experimenting a little bit. Get yourself some copper or brass, something with less value than the silver or gold, and have a play. If you have an idea of something, always write down your measurement so that if it does come out correctly, which sometimes you're lucky and it does, you'll be able to replicate it. So now we have a square ring, and it's ready to polish up on the Tripoli wheel. Nice and simple.